Hello everyone. So today I'm going to finish off my little diversion and talking about the op-return and how you can use that to basically encode little pieces of information into the blockchain using a Bitcoin transaction as a kind of a vehicle. In the first video, we talked about the op-return being used as a proof of existence by taking a hash of a document and encoding that in this special op-return field in the blockchain. So please watch that video if you don't really know anything about op-return, and it's a very quick video, and this is really kind of following on from that. It's kind of I guess a slightly silly subject, but I just want to show you another little fun application of the blockchain where you can actually take a message like "I love you" and encode it in the blockchain forever, right? So if you want to pledge your undying love to your partner or whatever, then you can just basically encode it in an op-return, stick it in the blockchain, and it will be there forever, right? And you can go back whenever you want and see that message. So again, it's not, this one's probably less useful, but it's just a kind of a bit of fun. But it really, see, this one is going to really show you, I think, more of the mechanics of how to actually create an op-return transaction yourself, because we're going to use this really cool Bitcoin wallet, and I'm going to take you through a step-by-step example where you can actually create and sign your own transaction encoding this special message, whatever you want it to be, in the op-return field, and then I'm going to show you how you can then search for that blockchain transaction, and with a bit of luck, so I'll put all the links down below, all the instructions, and you should be able to do this yourself. And it's a really good way, I think, to kind of understand the mechanics of the Bitcoin transaction a bit better. Okay, so let's get going. So the first thing I'm going to do, capturing my iPhone screen, is I'm going to go back to my Bread wallet on my phone, because that's where I have a little bit of Bitcoin left, and because we're going to do this special op-return transaction through a different wallet, which is actually based on my computer. Okay, so first of all, what I need to do is to transfer some Bitcoin. So I'm just going to go to Bread wallet on my phone here. I'm going to unlock it. A bit of Touch ID there. So you can see I've got about £4.31 worth of Bitcoin. So I'm going to send money here. I'm going to do scan QR code, and I'm going to, so it's picked up the amount. Sorry, it's picked up the address there. So it just tells me, okay, how much do you want to transfer? So let's transfer 4,000 millibits. So pay that. That's done. So with a bit of luck, in a second, we should see that balance reflected in my wallet. So I've funded my wallet with some more Bitcoin. I'm just going to show you quickly that transaction, just to kind of hammer the point home so we get more familiar with the blockchain transactions and the addresses. This is not what this video is about mainly, but I want to seize every opportunity to kind of hammer it home. So this is my Bitcoin address for this particular wallet, and if I look at the history, I can see that if I go to transactions, I can see that this is the transaction that I just initiated from my Bread wallet, and we now have two confirmations. It took a while for it to come through. It's never guaranteed that your transaction is going to make it into the next block. You just have to, it depends who's mining it. But here we go. So we see, if we just sort of paste this transaction ID, let's just click it, and then go to the slightly more familiar blockchain.info site, this one here. So here's the transaction. We can see it's got two confirmations, and here are the two outputs, right? So remember, I said I want to transfer a certain amount from my Bread wallet, and my Bread wallet decided which of my unspent transaction outputs to use for this transaction, and it paid the amount that I wanted to pay to my address, which ends in C7GV, which we saw over here, right? C7GV, and then it paid the remainder back to Bread wallet, right? So this is the one we're interested in, and happily we can now actually go back and we can now spend that Bitcoin, right? Because it's been confirmed. So what we're going to do now is to create an actual transaction using this transaction output that we've just spent in, and we're going to basically encode a message on the blockchain. Okay, so let's go ahead and do it. So now I'm going to actually create the transaction from scratch, right? So I'm going to go, this is my Bitcoin address, right? I know I've got this balance associated with this address, right? So I'm just going to copy this so I've got it on the clipboard. I'm going to go new, transaction. First thing I'm going to do is I'm going to enter my Bitcoin address. This Bitcoin address is going to be used to fund the transaction that I'm about to create. It's going to say, okay, if this is your Bitcoin address, go and fetch from the blockchain, go and fetch the unspent transaction outputs that are available for you to spend, right? So if I just do that and load, it says retrieved unspent inputs from address for this address, right? So these are the UTXO that I can spend. If you go into and then now it's a question of creating the outputs for the transaction to determine who's going to be paid by it, right? So first of all, though, for the OpReturn thing, we're going to go advanced options, and we're going to say null data, allow data to be sent within the transaction and stored in the blockchain by using OpReturn, right? Which is what this video is all about. So that's fine. Then the last thing we need to do is to look at the inputs and outputs, right? Because this process creates a more manual process of creating the transaction. So we've already specified these are this is the Bitcoin address that I'm using to fund the transaction. So if we go to the inputs tab, the inputs tab is already laid out for us, right? The inputs tab is basically, we've got these two transaction IDs are available to use as inputs, right? And this is all grayed out, right? We don't specify this manually. And the output side, here's where things get interesting, right? So first of all, I'm going to pay this Bitcoin back to myself, right? Because I don't actually want to buy anything here. I'm just putting effectively a dummy transaction on the network. I'll need to include a transaction fee in order for a miner to pick this up and be incentivized to put it into a block. But if I go back to my inputs, right, and I see, okay, so this is the transaction I just used to fund my account. I'm going to take this amount here, right? So 0.004, right, and I'm going to pay all of that, and I'm going to pay it all back to myself, right? So I'm going to, again, same Bitcoin address. I'm going to copy it from up there and enter it down there. So I'm paying this amount back to myself, right? The transaction fee down here, again, is grayed out because it's calculated automatically. So now what we have to do is we have to enter the OpReturn, right? So we enter the OpReturn, and there's no special way of doing it. All we have to do is, if you look at the message, it says, when using this option, you may enter a hex string or address into the address field on the output tab, right? So we need a hex string, which is basically a specially encoded form of our message that we want to include on the blockchain, right? So to create a hex string, and I'll put the link down below. There's a handy little converter here from Nathan Lex, so you basically, put a corny message like this, right? Like this. And so this is text, and then on the right hand side you want to make sure that hexadecimal is selected here, because hexadecimal is the format into which we want to encode this message, right? So if we just take this hexadecimal string, right, and then we go back and we can paste this in here, right? And for an OpReturn, we don't put any amount, right? You don't pay, you cannot pay Bitcoin to an OpReturn output, right? So if we submit this transaction, right? So in this green box down here, right? So if I can play around with these numbers here, right? At any time I can change this to 3 and submit, and all this does is basically this green box is taking everything you've entered here, right, in the entire transaction, and it is basically encoding it in hexadecimal, right? It's going to be a document that is going to be signed and propagated through the network. So if we change this number back to 4, because that's what we want to use, you'll see basically very little in the document changes, but you'll see one small change in the encoded string down here, right? So if I just do submit, right, it was actually just around here that one of the encoded amounts was changed, right? But overall, this big long encoded string in hexadecimal is what we're is the entire transaction content. So all we need to do now, we've got our transaction, we're including the very corny message in there, right? And all we do is we just copy this, right? We copy that, and then now what we have to do is we just have to go and verify this transaction. That's the next step, right? So we just go to verify, and it says enter the raw transaction that you want to verify. So I'm just going to paste all that hex output in there, right, and do submit. And here you can see our transaction, and this is really interesting, right? You can see, so here are the two transaction inputs that we've used to fund the transaction, okay? And here are the outputs. So the output is obviously, this is paying back to myself, right? The amount of 0.004 bitcoins, right? And it's picked it up as opreturn, right? So opreturn is the special output field that we're using, and here's our corny message in hexadecimal, right? So we can just copy this, right? And we just go to the sign button, right? So we go here, paste our transaction here, right? And then we need to enter the private key in this field, right? So where's the private key? Well, it's obviously in our wallet, right? This wallet contains the private key for the Bitcoin address that we're using, right? So I'm going to go to wallet, go to keys. I'm going to go to private key, right? And again, don't get too excited. If anybody on here wants to spend the Bitcoin that's in here, then please go ahead. I won't be reusing this address again. So that's the private key, and I am copying that, and I'm going to go back to the sign tab, and I'm going to enter it in there, right? Show there. That's fine. So the private key is used to sign the transaction. I'm going to go into what that means in terms of digital signatures in the next video, which I promised a couple of videos ago was the next step in actually really understanding how it is that UTXO is bound to a public key, right? But anyway, this is all about saying I love you on the blockchain, so let's postpone that headache for another day. Submit. And now the above transaction has now been signed. So this is now a signed transaction, right? Again, this is really cool. It's a very simple, logical sequence of operations. So we're going to copy this, and then we're going to go and broadcast this transaction on the Bitcoin network, right? So let's do this. So you just paste it in there, submit, and we have a transaction hash, right? So we have a transaction ID. Obviously, that transaction ID will not yet have been confirmed. It's still making its way around the network. It's probably reached most of the nodes already, but we have to wait some time before that transaction is actually mined into a block. So let's just pause for a while. I'll go make a cup of tea, and when I come back, hopefully we'll see a transaction with a corny message in the blockchain. So here we are. The transaction is not yet confirmed, but I've just gone to this blockchain explorer called blocktrail.com. I normally use blockchain.info, but blocktrail.com is better for browsing these opreturn statements, because some blockchain explorers don't show up opreturn transactions, right? But this one, Blocktrail, it does, right? So we can see, so this is our transaction ID that we've just propagated around the network, and you can see obviously it's still unconfirmed and it's going to take a while before that happens. But we can see that this is the transaction that we created manually with those inputs, the transaction output paying 0.004 Bitcoin back to myself, okay? And then operaturn. So the second output is an operaturn, view decoded message, right? And we can see down here at the bottom, right? We can see decoded operaturn and Coinbase messages. So this is the hexadecimal that we converted using Nathan Lex's cool little converter, right? 69206 blah blah blah, right? And over here, so basically that 69206 starts here, and then there are a couple of leading characters. But then here you go, I love you forever is on the blockchain, and in about probably, let's give or take 10 minutes, it will be a confirmed transaction in the blockchain, and that's a kind of nice way to put a geeky souvenir of some sentimental moment or whatever. And so let's come back in 5 minutes and just confirm that the transaction is well confirmed, and that will be the end-to-end process. So let's wait for that. All right, so I've waited a while, and I'm pretty sure that with a bit of luck, I'm going to show you how to find our transaction in a different blockchain explorer than we've been using so far. This is called SmartBit. Again, I'll put the link down below. This one's really good for searching the blockchain. So you can actually search in this particular blockchain explorer for the actual messages within, encoded within the operaturn statements across the whole blockchain, which is really cool and really powerful. You can't do that with the other blockchain explorers I've been showing so far. And I think it's good to sort of see different blockchain explorers too, to really kind of hammer home the fact that you are actually looking at one identical shared distributed data set that really is these are just presentation layers on top of it, but the underlying data is exactly the same. So if I'm just going to start typing away in this search box, right? So you can obviously put your normal search terms like the Bitcoin hash, the hash of the transaction, all that kind of stuff. You can see, so I'm not the first person who's pledged their undying love in the blockchain. I'm not sure what this person's on about, but I think ours was forever. Okay, still haven't quite got there, but okay, so there you go. I love you forever, comma M, right? Which is what we wrote before. So if I click on this, obviously this is going to take us to the transaction, and hopefully we're going to see here that this transaction has plenty of confirmations by now. So here we go. Here's our transaction. It should be familiar. You can see it was the C7GV Bitcoin address that I was paying back to myself. And then the operaturn section down here, you've got the message. So the text is hopefully familiar by now, and we have 17 confirmations now, right? So it's 17 blocks, or let's say, 17 blocks have since been mined on top of this transaction, meaning it is completely and utterly safe. 6 is what they say it takes to be virtually impossible that anybody could basically fork the blockchain and not include your transaction. So that's SmartBit. You can see this transaction on Blocktrail, etc., but you can't search for the actual text. So if you want to do your own message and then kind of show everyone just by typing and searching for it, then use SmartBit. So that's really that. So basically, in a nutshell, the process was we went basically create and validate and sign the transaction that you present, and then you broadcast that transaction. So that's really I guess hopefully like a slightly more fun exploration of what you can do with the blockchain, and I know that we are supposed to get back to the nitty-gritty, which is to talk about how the transactions are signed by the private keys so that only the owner of that Bitcoin address can actually spend the UTXO. I hope that some of the stuff that we're exploring here is kind of starting to ingrain the basic concepts into your mind, so that they'll perhaps be more familiar and I guess quicker to understand when we do the next video. It's going to be a bit heavy. So Yeah, thank you very much for watching. Please thumbs up the video if you liked it and managed to make it all the way to the end. Please leave any questions and comments. I love getting questions, and they're beneficial to everybody. And please subscribe if you liked it, so that you get the notifications. I'm doing these videos every week, and I think the good, the more subscriptions and thumbs up, all that kind of stuff, it helps to get, I guess, get the videos more prominent. And because I do believe that having a playlist like this, where you have a weekly video coming out that builds gradually the knowledge, is a good way to learn. And so I'm quite happy with the feedback I'm getting so far. It seems to be of use to people, and so I really hope to keep it going. So thank you very much for watching, and I will see you in the next video.